everyone. In the last lesson we were graphing quadratic equations, and in this lesson we're going to be graphing quadratic inequalities. So let's first talk about the difference between an equation and an inequality. You've done linear equations and linear inequalities. Remember, a linear equation, if you graph it, it's just that straight line and that's it. But if you graph an inequality, there's the straight line, which may be solid or dashed, but then you have to do some shading. So that's where you choose that point and decide if you shade this half plane or the other half plane. So the difference between a linear equation and linear inequality is with an inequality, it's all the points less than or greater than, as well as all of the points on the line sometimes. If it's just less than or greater than, remember it is a dashed line. So like this. So the lesson today, again, is graphing quadratic inequalities. If you understood graphing quadratic equations, this will be a piece of cake, because graphing inequality is exactly like graphing the equation, but with the added step of the shading. So to sketch the graph, remember we have to start with the opposite of b over 2a to find that coordinate of the vertex. Then you're going to construct the table of values with some x values greater than and some less than. You're going to plot the points, and then remember, if it is a greater than or a less than or greater than, it's going to be a dashed line. But if it includes it with the or equal to, then it's going to be a solid. So a dashed parabola or a solid parabola. Then you're going to choose a point to test. If you choose a point in the parabola and it works, you're going to shade in the U. If it doesn't work, you're going to shade outside the U. Alright, first problem. Y is less than x squared plus 4x minus 5. So remember, I highly suggest you pull out your A, your B, and your C. So A is 1. That's right there. There isn't anything there, so it's going to be a 1. B is 4, and C is a negative 5. So now we're going to do the opposite of B over 2A. So the opposite of B is negative 4 over 2 times A. So now negative 4 over 2 is a negative 2. So the equation for the axis of symmetry is x equals negative 2. And we know that the vertex x is negative 2. We still have to find the y. Alright, so to solve the equations, remember here is my vertex x. I chose some before and some after. And it's a matter of now plugging each of these into the equation to find what the output of y is. So when you're filling out, please remember to leave parentheses to put what the value of x is. That way you don't drop any negatives. So I did my framework all the way down, and then I'm going to plug in my values. And then I can start evaluating. And we know the easiest one is 0. 0 is our friend. So those two cancel out, so it's going to be negative 5. And then up here, negative 4 squared is 16, plus 4 times negative 4 is a negative 16 minus 5. So that cancels out, so we have a negative 5. So we look like we're headed in the right direction because these two are the same. And remember, we're going to work to a certain point and then it's going to reverse. So negative 3 squared is 9, plus 4 times negative 3 is a negative 12 minus 5. So 9 plus a negative 12 is negative 3, minus 5 is negative 8. And I can do negative 2 squared is 4, plus a negative 8 or minus 8, minus 5. That would be a negative 9. And 1 squared is 1, minus 4, minus 5 is a negative 8. And I'm going to look, I see my nice pattern here, And so I can start plotting my points, and I can also go back up here and finish my vertex. It is -2, -9. So after I plotted my points, remember I always round the bottom to make sure that it looks like a U instead of a V, and then I do both sides so they're symmetrical. So this was a skinny U. So to recap, we found our x-coordinate using the opposite of b over 2a, made it equal to x for my axis of symmetry. I set up my framework where I left parentheses where every x was. I filled in my numbers. After I chose some before and some after, I simplified without dropping any negatives. I wrote more work over here so I wouldn't have to do everything in my head. I plotted my points and drew in my parabola. The last thing I want to talk about is how this relates to the solution if we were solving the equation. Remember, if you solve an equation, what you're trying to find is what value you can put in for x to make a true statement. And so how this relates to the graph, again, is you see that what x is, if we have x equals, where it crosses that y-axis would be the solution. So when y is 0, what the solution is. Because remember, in standard form, it's ax squared plus bx plus c equals 0. So when y is 0, we have to find what x, I said bx and I put a squared, bx. So what it is when it's 0. So if we were using a graph to solve this equation or inequality, those would be the solutions where it crosses the x-axis. Now this is if it's an equation, but this is an inequality, so we have one last step. The last step is to choose a point inside the parabola. I'm going to, because I'm not exactly sure where it crosses here, I know that 0, 0 is on the inside though. So I'm going to choose 0, 0 on the inside, and I'm going to plug it into the equation for both x and y. Is 0 less than -5? It is not. So we know that for this inequality, we have to shade everything that is not in the parabola. And then lastly, I always go back and check, did I use a dotted line or a solid line? I used a solid, but because of this less than, we know that it has to be a dashed. So I'm going to go back and make it a dashed line. And some of you, even when it's kind of messy like this, even put dashed, so I know that's good.